Question 1. Forces of 55 newtons and 16 newtons act at a point and are inclined at 90 degrees to each other. Find by drawing the resultant force and its direction relative to the 55 newton force. Right, well, when you're drawing, the first thing you need is a scale. Right, so this is like a scale on a map. So we could say that, say, 1 centimeter equals 10 newtons. So look, what will 55 newtons equal? Well, 50 newtons would equal 5 centimeters. So 55 newtons is going to equal 5.5 centimeters. And in a similar way, 1.6 centimeters is going to represent 16 newtons on our drawing. So you would have a ruler, piece of paper, and your graph paper is best, 5.5 centimeters. So I'm going to say that each of these two blocks, that's 1 centimeter, 2, 3, 4, 5, right, and a half. So I'd have to draw a line from here out to there, and that line there represents, that line is, I'm pretending it's 5.5 centimeters long, 1, 2, 3, 4, 5.5. And then I'm going to have a 1.6 centimeter line acting at the same point, but it's at 90 degrees, so it's going to be going up this way, 1.5 and a bit up to about there. See, so you'd have to do this with a ruler and a piece of paper, and if it was any other angle other than 90, you'd need a protractor. Right, so that's 1.5 and a wee bit is 1.6. Now, find by drawing the resultant force. Well, using the parallelogram method, I can draw another line over here, like this, opposite my 1.6 line, right? There it is there, and then I can draw another kind of a line over here, kind of mirroring my original, my 55 newton line, right? So this is 55 newtons here, and this is 16 newtons, and using this parallelogram method, the resultant is going to be the diagonal. Right, so the resultant is going to be the diagonal, and the more accurately you draw it, the better your result is going to be. And we can put a wee arrow on that. So this here is the resultant. It's the combination, if you like, of the two forces. And we need to get the magnitude and angle of this resultant. We get the magnitude in by measuring it. Unfortunately, I can't show you how to measure this angle here. We'll call this angle here theta. Right, that's the angle it makes with the 55 newton force, the resultant does. So you'll measure that using a protractor. And when you measure that, you should come out with theta equals about 16 degrees, approximately. 15 or 16, right, depending on how accurate or how big you draw it. And then we need to measure the length of the resultant. Now, when you measure the length of the resultant using a ruler, you should get approximately, for the length of the resultant, resultant resultant length on your page, if you use the same system as me, should be about 5.7 centimeters. And using our scale, 1 centimeter equals 10 newtons. You get your 5.7, multiply by 10, and you'd end up with 57 newtons. So find by drawing the resultant force. So the answer is the resultant force, let's call it R equals 57 newtons, and its angle is 16 degrees. Now we're describing it in relation to the 55 newtons, so you could say 16 degrees this way, so that could be described as anti-clockwise, clockwise, or maybe north of, but anti-clockwise from the 55 Newton force. That's your answer there by resolution with drawings. Now you could, another way we could have went tail to head, but this is the kind of diagonally method.